So here we have a simple harmonic oscillator. I've got this long spring, and I've held it with two clips between handrails, and I've got my knitting needle here that's just a marker, and I've got a little timer that you can see, and then here's a length scale, and I've got a nut on there. That's a 3/8 16 nut. I'm going to give this a small displacement and we can watch it oscillate. So the oscillation is going to be related to the mass that I have there. So this is weighing the nut, so to speak. We're determining the mass of the nut based on oscillation period. The period for this one, I measured it. The period for 20 oscillations, complete cycles, is 21.26 seconds, and it's incredibly repeatable. And now we're going to put a different nut on here. This is a 1032 nut. Look at that. It's oscillating at a higher frequency. This nut does not have as much mass, and it's oscillating at a higher frequency. The period for this I measured was 10.7 seconds for 20 oscillations. Okay, here's a quarter 20 nut. I counted for 20 oscillations on this, I counted 14.2 seconds. Now, this is a pendulum, and of course a pendulum doesn't work in weightlessness. This is just the end of the pendulum right here. I've got an 84 gram mass, and I'm using Legos as the pendulum stick. And of course pendulum requires gravity. It's a gravity machine, and it just doesn't work. It just sits there. Now, I'm going to do a little modification to this pendulum. I've got a long, weak spring right here. And if I put the spring on like that, now, for small angle displacement, this spring will exert a constant force. And it's a small force because it's a long, weak spring. It's almost a meter long. To first order is going to appear like gravity. So this pendulum now is going to swing and behave just like a pendulum on Earth, where instead of gravity, we're using the force in this spring. And I'm also going to change the length of the pendulum and show that that is what varies the period, is the length of the pendulum, not the mass. So the pendulum's 5 inches longer than before, and it's swinging slower. Here's the pendulum in its shortest configuration. It's got 3 Lego lengths. Now, I'm going to double the mass. So now we have 168 gram mass instead of an 84 gram mass. And it turns out something interesting is going on, because when I measured the period, I got about 7.9 seconds for the period at 3 lengths with 168 gram mass. But when I only had the 84 gram mass, it was more like 5.8. So something interesting is going on. There is a dependency on the mass on this pendulum. So perhaps the spring does not exactly replace gravitational force, and it's behaving a little bit like a simple harmonic oscillator. So it will be interesting to see whether maybe this is a combination of both a simple harmonic oscillator, which is mass dependent, and a pendulum, which is mass independent but length dependent. And of course, this is all freshman level physics, which is delightful stuff to learn.